Hello and welcome to our video on spanning tree. Okay, so we're up to the point now where we've configured our trunk ports here and here, and we've configured our access ports here. Now we've not put any IPs on the compute layer at the moment because, as we know, because this is now a layer 2 topology, we're going to have some spanning tree loops and we won't be able to ping from device to device. So while it's not part of the curriculum, they will still expect you to know a bit of spanning tree, not a lot, not the basics. I mean, it's not in the blueprint, and I don't recall seeing it on the exam. How you can't really implement layer 2 unless you know at least how to put some sort of spanning tree on. So what we're going to do, we're going to put VSTP or VLAN Spanning Tree on. Reason being is that it's generally considered best practice if you're in a topology that has multiple VLANs, not to just run plain old Rapid Spanning Tree Protocol, RSTP, which is fine. You can do that, but you really want to isolate what you're doing. Reason being is that we might want this router, this switch here, to be the route for say VLAN 200, and we might want spine 1 to be the route for VLAN 100. So therefore we maximize our links and we maximize the amount of throughput we can get, because if we was to just use RSTP, then we would find a lot of these links would actually go down. I mean, say without going through the MAC addresses, I'm not 100% sure, but we'd say this link would go down completely, say this link will go down, and say this link will go down. So we would lose 3 of our 6 links. We won't be transversing traffic across them at all, and that's something we actually don't want. We want to ensure that all of our links are remaining, which is why in a traditional in a modern data center now, they use IP fabric to get away from having to use spanning tree. But again, you can't learn layer 2 and see what a layer 2 network looks like unless it actually works, and it's not going to work without having some spanning tree running. So it's a bit of a catch-22 situation really, but let's get cracking. So let's jump onto the command line and let's jump onto leaf 1. So let me double check what this interface is here first. So we have interfaces, and so link from leaf, let me just get that up, and that is port 1 and that will be port 2. Okay, so great, let's jump on to leaf 1. So we have our leaf 1 here, and let's log in. Okay, and let's do CLI and configure. All right, so first we're going to do is go into our protocol. So we're going to do set protocols, and it's VSTP for VLAN Spanning Tree Protocol. And if we do a question mark, we see we have quite a lot of options here, not as many as you'll see in some other things, but we have a few. So what we're going to do, we're going to do our VLAN, and we'll do all. So we're going to allow VLAN Spanning Tree to run on all VLANs. And now what we're going to do, we're now going to do set protocols VSTP, and we're going to do interface, and it's going to be XE 0/0/1. Now if you try to use the sub interface, you get a failure on that, so it has to be the main interface on this. And we're going to do the same for XE 002. And let's commit, let's do a commit check. Sweet. Okay, so that's fine. Let's commit that. And let's jump up to spine 1, seeing as the spine is the next one in the list. So we have, what have we got here? C001 on the spine. So let's set that up on the spine. So let's go root and the default password of Juniper, and let's do a clear because we're in the Unix shell at the moment, so we can use Unix commands, and CLI and configuration. Okay, so let's do set protocols VS and we're going to do what interface is going to be on. So interface is going to be XE, and it's going to be 0/0/1. And let's do again set protocols VSTP. Oops, VSTP. And what we're going to do, we're going to give it what VLAN we're going to do in this priority. So VLAN 100, and we're going to do a bridge priority. The bridge priority, we'll put that as 28K, so this will be the route for VLAN 100. I've already configured spine 2 to be the route for VLAN 200. And let's do set protocols VSTP VLAN 200. Now, because we've not set a particular bridge priority for VLAN 200, it's going to have the default bridge priority of 32K. So this will not be the route for VLAN 200. Well, it will, but once we've actually done the link between the two spines, then it won't be. All right, so let's do a show pipe compare. Sweet. Okay, that looks good. So we have our VSTP, our interfaces, it's running on XE001, our VLAN ID is 100, the bridge priority is 28, and we've just got VLAN 200 with no priority on there at all, so it's going to be 32,768. Let's commit that. Commit check. Alrighty. Okay, so our spine and our leaf are now connected via so not connected, they now have VLAN Spanning Tree running on them, which is great. So what we'll do, we'll get the link between spine 1 and spine 2 set up. And let's just see what this is. This is GE000 on both. Okay, let's have a little look here. So let's do set protocols VSTP interface GE XE 0/0/0. All right, and let's commit that. So where we up to now then in this case is we have our spanning tree set up on leaf 1, which is exactly what we want. So we have spanning tree on this interface, spanning tree on this interface, and we have spanning tree on this interface. This has been set as the route for VLAN 100. This has been set as the route for VLAN 200, and we have VLAN Spanning Tree on these links. So we're going to enable this link now, and then we should see the routes change, because at the moment, because there's no direct communication between spine 1 and spine 2, as far as they're concerned, they are the route for both VLANs. But as soon as we have Spanning Tree enabled on that link, that will change. So let's get that and jump on to spine 2, get rid of that, and bring up the command line. Okay, so let's jump onto spine 2. Okay, and let's do a set protocols VSTP interface XE 0/0/1. Okay, let's commit this, and let's have a look at the configuration on this one. So let's do show protocols VSTP, and you can see that the configuration is the same apart from the VLAN 200 as a bridge priority of 28K. So let's now have a look and see if we can confirm this and validate this. So let's do run show spanning tree bridge. Alrighty. So what we can see here is that for VLAN 100, the route ID is 28,770 whatever, and the MAC address of the interface. We can see that we have no cost involved to the actual route, and if we have a look at the local parameters down here, our own bridge ID, as we can see here, matches the bridge ID of the route, as we can see up here. So we know that this is the route for VLAN 100, and it's showing up as RSTP RSTP under the enable protocol. Even though it's VSTP, it's still part of the RSTP family, so that's looking fine. So let's drop down one. Now if we have a look here for VLAN 200, we can see the root ID here is, well, that's actually different to what our bridge ID is. We now can see we have a port cost of 4,000 to get to the actual route. We can actually see that our root port is XE001, and we can see the actual bridge ID of their ending DCO2 is us. So what we expect is, if we jump onto spine 2, we should see that this MAC address here, F902, is the actual route, and it would then be the local as well for that route. So let's have a little look. Okay, so we're on spine 2, so let's have a look at the bridge detail again now. So let's do show spanning tree bridge. Excellent. Okay, and now we can see that for VLAN 100, the bridge or the route is ends in FE02. We have a port cost of 2000. We're directly connected, XE000, which is the link between the two spines, and our local bridge priority is D102. So we know that we are not the route for VLAN 100. However, VLAN 200, we can see that we are the route. See, we have D102 and ourselves D102. We don't have any exit interface or any cost. So it looks like per VLAN Spanning Tree is running absolutely fine. Okay, so what I did, I've gone along and put the IP addresses on. So the IP addresses on our servers are 10.10.100.1, 3 and 5, and 10.10.200.2.4.6. So what we're going to do, let's have a little look, see if we can ping and therefore generate a little bit of traffic. So in the next video, we can start examining the MAC address tables, or the Ethernet switching tables as it's called in the Juniper land. Okay, so let's jump on to, let's say, server 1, and let's do a show IP. So we can see that we're 10.10.101. Okay, so let's do a ping, and let's do 10.10.100.3. Sweet, there we go. So we're getting communication on that, not a problem. Let's jump over to server 3, and let's do a show IP. As you can see, this is the 10.10.103. Let's ping 10.10.100.1. Okay, great. So we have reachability on VLAN 100. Let's have a look on server 2, and let's do ping 10.10.200.4. Sweet. And let's go on to server 4, and as you can see, we're able to ping server 2 no problem. So what's happening is that we're having traffic going from server 1 up to leaf 1, up to spine 1, down to leaf 2, and down to server 3. So it should be going in this sort of direction. So it's going up there, and down to get from server 3 to server 1. So server 2 to server 4, it's going up that direction. It's going up to spine 2, and then down from spine 2 to leaf 2, and down to server 4. So it looks like our spine and leaf topology is working a-okay, which is fantastic. That's exactly what we want. In the next video, we're going to have a look at the Ethernet switching tables, and I look forward to seeing you then.